Good evening, everybody. As you know, I am Summer Malillo. This is my first capstone project of this semester. I decided to do a car temperature sensor that would turn on two fans that are located in the back of my Mazda CX-5 um, to help keep my competition dog cool during the summer, or as I found, since it's winter, when it's hot in the front of my car when I like to be warm and he does not like to be warm, that's what it's being used for right now. With that, let's move forward. Um, Obviously the purpose of the project was to implement a cooling mechanism for the back of my vehicle so that when it's too hot outside or the inside of my car, the fans will turn on. The focus of the project was to ensure that the fans will turn on when the temperature reaches 75 degrees, and when the temperature sensor reaches 65 degrees, it will turn off. I will go over the materials needed for this, sketch of the circuit without being hooked up to the fans at the time. I'll show you the function tests. I'll show you kind of a funny video, complications as I call it, and then a couple working models, and then we'll go over my references. So the materials needed, I needed a 12-volt cigarette lighter that plugs into the back of my car. There was an optional, I just happened to find it, there's a cigarette lighter that had a switch built in, so I decided to use that. That way it wasn't turning on when there was no dogs in the back of my car. You need two 12-volt slim cooling fans. I ended up using radiator fans because they're slimmer and they did not have a back to the fan, so they only had one side of like a protector or a cage to the fan. You'll need a DHT11 temperature sensor. You could use a thermistor, but I ended up using a DHT11 because that's what I had laying around from last semester for another one of my classes. But that's what I used. You'll need a 220 ohm resistor, an NPN transistor, 10 UF capacitor, a diode, and a Arduino Uno card. So here's the basic sketch of my circuit. The thing to note here is that on the far right side, as you're looking at it, that's a DC motor that's representing the fans. So my actual sketch, when you see it, will look slightly different because there's not enough rows for both DC motors to be hooked up on the same line. As you can see, already running out of space, so I just put a jumper to the next line over. But basically the way this works, and I'm using a 9-volt battery also to simulate the 12-volt input, as when the program I was using to make this sketch didn't have a 12-volt battery or a different power supply or power source. But the power comes in, it will run through the board powering the two rails. It will power up the DHT monitor, the DHT11, and that will send the signal, that analog signal, to A0 of my inputs. The inputs will then wait until the monitor or the temperature hits a certain degrees. At this point it would be 75 degrees. It will send that signal to the input or output 9, which is a pulse width output. It will send it over to the resistor, which will go through the transistor, and then it will go into the capacitor, diode, and then it will go into the capacitor, diode, and then go to the DC motor, or in this case, two fans. So this is the way it looks on paper. This is the actual one, and the biggest thing you'll notice here on this picture is that I ended up going with the input or output 3, the digital output 3. It just happened to work better when it was in the box. There was less wire that I had to deal with and made it nicer. And I'm all about cable management. So, alright, so these are some of the function tests here that I wanted to show you guys, that when I was doing my analysis of things, I think it's important to test everything as you're going along. Some of you guys might have seen these when I posted them as my as I was going along, but this is the fan when I first set it up. I had to flip the blades inside out, or flip the blades, and to ensure that the air was blowing into the box and not being blown out of the box for no reason. The next one that I have is the switch. I was just testing the switch in my truck just to ensure that it actually worked and I didn't have to repair anything else. The next one I have for you guys is me actually testing my code that I wrote and the hair dryer blowing against that temperature sensor, and the far right you can see that the temperature is going up. H stands for humidity, and C is the Celsius, obviously. I just want to make sure the whole component works, just in case. You see it's dropping. Hair dryer has a cooling button on it, so utilize that. So every 1 second it's actually sending that signal to the board. So there's that. And this last video I have is showing that the fan is actually working. It's very basic, just setting it up to read. Oops, yeah. So it's just basically how it's set up, you know, power to it, ground's over this way, another ground. Input signal is the black cable, power is the blue cable. But it was just basic setup. I didn't put any resistors in that. I just wanted to make sure that my fan, or it would turn on the fan at the lowest level when I was testing it. So the next part of this I have for you guys, if I can do this, is slowly as it comes back. Is some of the complications. So this is kind of a funny video. So I sent a video last week to you guys showing that my circuit was working. I let it sit in my car a little bit longer when I was driving down the road, and I noticed a kind of that electric burning smell. And so this was kind of interesting that I found that the board had actually caught on fire. A little component right here had actually set on fire, and the fans were going pretty good. So I knew there was a short in my board. So I had to actually end up replacing that with a new board, and so I ended up doing that. And so after, you know, this was my first test for I showed you guys as everything was working. So I had everything ran up. There was nothing wrong with my setup. I left this all exposed for you guys, so you guys could just see. I'm kind of glad I didn't put everything down, or because obviously in this video you can see that the board hasn't caught on fire and it hasn't done anything crazy. Here's where I try to get it to actually turn on. try to warm up that sensor because I couldn't find an extension cord for some reason. I guess that was too much for it, you know. But I ended up trying to heat it up with my breath, and you can see I slowly got it to turn. But so it ended up working, but after a while it ended up setting on fire, as we saw from the last video. And then just this last week, I was coming home from dog training, and I'm talking to you guys in this video, but basically what I'm telling you guys is that I don't know what I'm trying to say, is that I set the sensor right on the back of my car seat because I did notice that it wasn't kicking on because it's not very warm down here right now. It's not warm anywhere. Maybe it is where you guys are. But in the front of my car, it's actually really warm because I like to keep it warm there. I get cold pretty easily. So I set it there, and I had just got home from training. It was kicked on, and so I did want to show you guys this, and I will fast forward this slightly because you don't need to see my face any longer. I don't like to see my own face. But I just got home from training. Both fans are on. I had my gear in the other box because I didn't have another dog with me. But obviously he's not panting, which was the whole goal of this project, was to make sure that he was safe and kept cool while we were out training. So he seemed pretty happy about it. So that is my project. These are some of my references that I used to help make this. And that is all I have for you guys for that. Thank you.